In the spring of 2002, a crew of wildlife biologists drove a convoy of modified trucks across a stretch of shortgrass prairie in southern Colorado and started pushing small animals into the ground with pneumatic tubes. Not one or two, not 100, thousands. Prairie dogs, alive and disoriented, vacuumed out of one patch of earth and deposited into another that hadn't heard that sound, the sharp bark, the territorial thump in decades. The land they were releasing them into had been poisoned, farmed, fenced, and largely forgotten. And within a season, something started moving underground that nobody had put there. I'm Tom Marsh, and this is the story of what happened when Colorado handed 250,000 acres of dying grassland back to the most misunderstood rodent in North America. Most people who've spent any time in the American West have an opinion about prairie dogs. Ranchers consider them a hazard, a network of burrow entrances that can break a horse's leg, a competitor for the grass their cattle need. Farmers have spent the better part of 120 years poisoning them, trapping them, flooding their colonies with carbon monoxide. At the peak of the eradication campaigns in the early 20th century, the U.S. government funded and organized some of the largest coordinated wildlife kills in the country's history, targeting prairie dog towns that once stretched, according to historical surveys, across hundreds of millions of acres from southern Canada to northern Mexico. One colony documented in Texas in the early 1900s was estimated at over 400 million animals. By the time serious conservation attention arrived in the late 20th century, that range had contracted by more than 95%. The prairie dog hadn't just lost ground, it had nearly lost the argument for its own existence. What the eradication campaigns didn't account for, because nobody was asking that question yet, was what prairie dogs were actually doing to the land they lived on. The Comanche National Grassland in southeastern Colorado sits in a part of the state that most Coloradans don't think about. No ski resorts, no famous peaks, just a broad, flat, slightly tilted sweep of high plains that looks from a highway like very little is happening. The soil is thin, the water scarce, summer temperatures push over 100 degrees, and for much of the 20th century, significant portions of it were chemically treated to remove prairie dogs and then leased for cattle grazing. By the early 2000s, the U.S. Forest Service was managing the Comanche grassland and watching the ecological data trend in one direction. Grass cover was degrading, soil compaction was increasing. The species that depend on heavily grazed shortgrass, the ones that need burrows, open sight lines, disturbed soil, were declining or absent. The black-footed ferret, North America's most endangered mammal and a specialist predator of prairie dogs, hadn't been seen in the wild in Colorado in any meaningful number for years. The mountain plover, a bird so tied to prairie dog colony structure that it nests almost exclusively in the heavily cropped vegetation around active towns, was in free fall across its range. The burrowing owl, which doesn't dig its own holes but moves into abandoned prairie dog burrows, was becoming a rarity in areas where it had once been common. The grassland wasn't just missing prairie dogs, it was missing everything that prairie dogs support. And what made it worse was that the land itself had changed. Decades of poisoning, overgrazing, and agricultural disturbance had altered the soil chemistry and vegetation structure in ways that made natural recolonization prairie dogs, simply moving back in on their own, essentially impossible at any meaningful speed. They needed help getting back onto ground that had been taken from them by deliberate human decision. But here's where the story shifts, and why this particular project is worth your attention. The land they were trying to restore wasn't just degraded. Parts of it had been treated with zinc, phosphide, and other rodenticides so persistently for so many years that the toxicity lingered in the soil. Prairie dog populations at the edges of the target area showed signs of secondary poisoning from residual compounds. The team knew they couldn't just move animals in and hope. They needed a reintroduction protocol, a translocation strategy, monitoring infrastructure, and enough political will to hold the space against the ranching interests that had long shaped land management decisions on the Comanche. None of that was easy, and none of it was guaranteed to work. The first translocation efforts were small and cautious, and the early survival rates were not encouraging. That's the part of rewilding stories that tends to get left out the years in the middle when the answer is genuinely unclear and the scientists are reading data that could still go either way. The prairie dog has a social structure built around what researchers call coteries, tight family groups, typically one male, several females, and their offspring, sharing a defined territory within the larger colony. The communication system between coteries is extraordinarily sophisticated. Their alarm calls can convey information about the size, shape, speed, and direction of a predator, information dense enough that animal communication researchers, including Dr. Kon Slobodikov at Northern Arizona University, spent decades documenting what he described as a functional language, with the calls encoding specific physical descriptions of specific individual threats. When you move prairie dogs out of an established colony and deposit them into unfamiliar ground, you're not just displacing animals, you're disrupting a communication network, a social map, a system of shared knowledge about where it's safe to forage, where the escape routes are, and which neighbors can be trusted. The early mortality in translocation projects is often not starvation or direct predation, it's disorientation animals that don't yet know the landscape they're in well enough to read it. What the Colorado team, working with the Forest Service and partner organizations, found over successive seasons was that survival improved significantly when they translocated family units rather than individuals. Moving coteries, intact animals that already knew each other, already had a shared communication context, gave the new colonies a social foundation to build on, instead of asking each animal to start from nothing in hostile terrain. It sounds obvious in retrospect. At the time, it required careful coordination in the field, a different trapping approach, and a longer timeline. But the data, tracked across multiple release sites over the better part of a decade, showed the difference clearly. And then the grasslands started doing something. Within 2 to 3 seasons of established prairie dog colonies at sufficient density, the vegetation structure around the towns changed. Heavily cropped shortgrass, the kind that mountain plovers need, appeared. Bare soil patches opened up in the colony interiors, exactly the disturbance profile that creates nesting habitat. Burrowing owls moved in without being invited, using abandoned and secondary burrows. The soil in active colony areas showed measurably higher nitrogen levels compared to ungrazed control areas nearby, a consequence of prairie dog foraging, burrowing, and the concentration of predator activity that comes with any prey-dense location. The burrow network itself, which can extend 8 feet deep and span hundreds of square feet per entrance, began restructuring the soil hydrology, creating pathways for water infiltration in a landscape where the topsoil is hard-packed enough that rain often runs off instead of absorbing. None of this was placed. None of it was engineered. The prairie dogs didn't know they were restoring anything. They were doing what prairie dogs do. A 2019 study published in the journal Ecosphere, examining prairie dog reintroduction outcomes across multiple sites in the southern Great Plains, documented that re-established colonies consistently increased local plant species diversity, soil nutrient availability, and invertebrate abundance compared to adjacent ungrazed areas, with effects detectable within 3 to 5 years of colony establishment. 3 to 5 years. On ground that had been ecologically simplified for decades. The prairie dog, the study authors noted, functions as what ecologists call a keystone species, a species whose ecological effect is disproportionately large relative to its biomass. Remove it, and the system simplifies. Return it, and the system complexifies, rapidly and without further instruction. But nothing in this story moved faster than what happened when the black-footed ferret came back. The black-footed ferret is one of the more dramatic conservation cases in North American wildlife history. By 1979, it was officially declared extinct in the wild. Then in 1981, a ranch dog in Meeteetse, Wyoming, brought a dead one home, and a small wild population was discovered. That population was devastated by canine distemper and sylvatic plague, a flea-borne bacterial disease that spreads through prairie dog colonies and kills both prairie dogs and the ferrets that depend on them. And by 1987, the last 18 known individuals on Earth had been taken into captivity. 18. The entire species, concentrated in 2 facilities, kept alive by a captive breeding program that operated under constant uncertainty. Reintroduction into the wild required prairie dog colonies large enough and stable enough to support ferret territories. A single ferret needs roughly 100 to 150 acres of occupied prairie dog colony to meet its prey requirements across a year. The Comanche and the broader shortgrass prairie network in southeastern Colorado, as it grew and stabilized through the early translocation work, eventually became one of the candidate sites for ferret reintroduction as part of the U.S. Fish and Wildlife Service's ongoing recovery program. The ferrets arrived with their own protocol preconditioned for wild prey, monitored with ear tag transponders, tracked through spotlight surveys in the early hours of the morning when they're most active. The initial survival rates, as with the prairie dogs before them, were uneven. Plague remains the single greatest threat to ferret recovery anywhere in the Great Plains, and managing it requires ongoing oral vaccine distribution across prairie dog colonies. Small peanut butter-flavored baits, laced with a sylvatic plague vaccine, dropped by hand and eventually by drone, across thousands of acres. The logistics are significant. The commitment required is long-term and unglamorous. And yet, ferret activity at the Comanche site, tracked through the monitoring program over successive years, showed reproduction in the wild. Kits, born in the burrows of the prairie dog colonies that had themselves been rebuilt from near nothing, in soil that had been poisoned and abandoned, in a landscape that much of the American West had written off. The offspring of the 18 survivors, hunting at night in southern Colorado because enough of the grassland had been given back. There's a word worth pausing on here. The Comanche. It's a name most Americans know as the name of a people, the Nomo, whose territory once covered much of this exact stretch of southern plains. The prairie dog towns that European settlers and their government spent a century destroying were, in the Comanche Nation's territory, woven into a landscape that had been managed, traversed, and understood by human communities for generations before the eradication campaigns began. The name on the national grassland is a survivor. The prairie dog is becoming one again. What strikes me most about the Comanche story, and I've spent a lot of time with it, isn't the ferret. The ferret is the headline, and it deserves to be. But the deeper thing is the speed. When you look at the timeline, early 2000s, translocations, mid-decade colony stabilization, vegetation response within 3 to 5 years, ferret kits within roughly 15 years of serious intervention, you're looking at a damaged and poisoned piece of land returning measurable ecological complexity inside a single human generation. The conventional wisdom for much of the 20th century was that land, like this land that had been that comprehensively degraded, needed either enormous technological intervention or an impossibly long time to recover. The prairie dog data suggests something else. It suggests that the complexity was never gone. It was waiting, encoded in the behavior of an animal, small enough to hold in your hands for someone to put it back in the right place and stop poisoning the ground beneath it. We didn't rebuild the shortgrass prairie. We returned the animal that knew how to do that, and we got out of the way. That is, I think, the most uncomfortable and the most hopeful thing the Comanche Project demonstrates. Uncomfortable because it means the loss was a choice, a sustained, funded, government-supported choice, and the recovery is also a choice, requiring the same political will to maintain. Hopeful because the system still knows what it's supposed to be. The ferret didn't have to be taught to hunt prairie dogs. The mountain plover didn't have to be shown where to nest. The burrowing owl didn't need a map. The instructions were still in there, and the moment the habitat was sufficient, the behavior switched on. That's what this channel keeps coming back to, video after video, ecosystem after ecosystem. Not that nature is indestructible, it clearly isn't, but that the blueprint survives in ways we keep underestimating. The grassland remembered, the ferret remembered, and the prairie dog, moved by hand across poisoned ground in pneumatic tubes, rebuilt a world it had never personally seen intact. I want to know what you think about that. We're watching more reintroduction programs come online across North America and Europe right now than at any point in conservation history. Wolves, lynx, bison, beavers, and species most people have never heard of being moved back into landscapes that lost them within living memory. Some of those decisions are controversial. Some of them are going to fail. Some of them are going to do what happened in Colorado in ways that will take decades to fully document. Is that a trade worth making? Drop your answer in the comments. I read them, and I mean that. If this story landed with you, share it with someone who's hit that wall of bad environmental news and stopped looking for reasons to pay attention. There are more stories like this one than most people realize, and I have many more to tell you. I'm Tom Marsh. Thank you for watching.